Hello, family. Welcome to another episode of MathsFanatics247. Here in front of us is a question on optimization taken from a past paper. Okay, so let's read the question. In the diagram below, ABC is an equilateral triangle with sides D units long. So if it's an equilateral, I know that this whole side, this side, oh, let me use a different color. I know that this side will also be D, right? All the sides are equal, remember? So this side will also be D. And also this whole side will be D as well, right? Perfect. And then I know that all the angles must be 60. So that angle will be 60. This angle here will be 60. Okay, of which makes this one 60 as well, right? Perfect. All sides, all angles are the same for an equilateral triangle. P and S are points on AB and AC respectively. We can see them then there. Q and R are points on BC such that PQRS is a rectangle. Oh, if it's a rectangle, I know that this side must be equal to that side, right? This side must be equal to this side. Then I know that all the angles must be 90, right? 90, 90. So if this is 90, that must be 90 then. Then this must also be 90, right? And then I'm going to have 30. Here I'm going to have what? 30. Because of angles in a triangle must add up to 180, right? And then here I'm going to have 60. Because angles on a straight line must add up to 180. Here I'm going to also have what? 60. Perfect. And then now I think I have another equilateral triangle, which is this one here. Do you see it? Because all angles are the same. So it means this side, that side, and that side are going to be the same. So, ladies and gentlemen, you always analyze your diagram and put as much information as you can before you even go to the question. Okay? And then obviously, I can see that if this is 2y and that is 2y, then QR, which is from here to here, will be given by D minus 2y minus 2y, right? Which means I'm going to have what? I'm going to have D minus 4y. So my QR is D minus 4R. Do you get it? I'm sure it makes sense now. Okay. So yeah, that is my analysis. I can now try to solve the question. They say show that the area of the rectangle is shown by this. Okay. So I need the area of the rectangle. Remember, area in this case is gonna be given by QR multiplied by QP. Right? This by that, or you can say that by that. Here, this part I have, so it's sorted, but I don't have this part, right? But if you check here, I have a right angle triangle, right? I have a right angle triangle. If this is my reference angle, this will be my adjacent. This side will be my op. And then this side will be my hype. Yeah? Hype. Sharp. Then I can now do SOHCAHTOA, right? Okay, remember on SOHCAHTOA, SOHCAHTOA, right? I'm gonna use something that has adjacent. Why? Because of that 2y being the adjacent. So it's either use cos or tan, right? So the sign is out. And then I'm showing you how to decide. Remember, we chose that because we have this and that. Now let's check, what are we looking for? We're looking for opposite. So obviously this is out. We have to use tan, right? Okay, perfect. Therefore, tan 60 degrees is equals to my opposite, which is QP, over the adjacent, which is 2y, right? Now let's see what tan 60 is on a calculator. So tan of 60 is what? Square root of 3. Okay. So this changes to square root of 3 equals to QP over 2y. So this is over 1. I'm going to cross multiply here. So I have 2 square root 3y equals to QP. Ne? Oh, now I'm sorted. I can substitute into my formula. I mean my area formula, right? Let's do it here. So equals to my QR, remember, is this, right? Is D minus 4y. And then multiply by 2 root 3y. I can rearrange it to say 2 root 3y in bracket, then D minus 4y. Then I'm sure you can see that that question is being answered. We got the exact same thing with that one there. Okay. Okay. Let's do 11.2 now, right? So in 11.2, remember our area formula is this, ne? Is 2 root 3 y and then D minus 4y, right? And then if you check here, they want us to determine the maximum area. Remember with calculus, the maximum area is going to be when we derive and get 0, right? Remember for minima and maximum, we derive and equate to say equals to 0, okay? So firstly, before I derive, I need to write my area in simplified form, ne? Sharp. So it's gonna be 2 root 3 dy, right? Minus 8 root 3 y squared. So you multiply this and that, it will give you this one. Then when you multiply this and that, is going to give you that one, right? Now we can do the derivative equals to 0, right? For maximum. So they say with respect to D, you see, in terms of D. Awesome. So I'm going to differentiate here. I'm going to differentiate. Awesome. So now let's look at this. Let's look at this. So we're going to derive with respect to y, because they say we must write in terms of D, right? Perfect. So they give you a hint here on as to which letter you have to derive in terms of, because if they said you must write this in terms of y, right? Basically, you were going to derive in terms of D, and then, but that was not going to make sense. The D was going to disappear, and then you'll just get the y value that gives you the maximum. Makes sense? So now, here I'm going to derive with respect to y. Ne? So remember these rules. Ne? Derivative of x equals to 1. Ne? Derivative of a constant equals to 0. So this is y is like x in this case. So for the first part, I'm just left with 2 root 3d. Ne? The y disappears, right? Here I have y squared. So I'm going to have minus 16 square root 3. Then remember, I have to minus 1 on the exponent. So I'm left with y to the power 1 now. Okay. Now I need d to be, right? I need what? I need y to be alone now, because I need to substitute d on the original formula, because they said with respect to d. Ne? So I'm going to isolate y here, so that those y's are going to be replaced. That makes sense. This y is here. Awesome. So I'm going to say 2 root 3 d is the same as 16 root 3 y. I move this to the other side. Then I'm dividing both sides by 16 root 3. 16 root 3. Then this will cancel that. Then this cancels that. So for this side, I'm left with y. Then for that side, I'm left with d over 8 because this will simplify to 1 over 8. So I have d over 8, right? Now I'm going to take this and substitute it here and there. Does it make sense? Perfect. So I'm going to have root 3, right? Where there's d, I put d, and then when there's y, I put d over 8, right? Remember, this is the area. I'm substituting into this step. I'm taking this, putting it there and there. So I have minus 8 root 3. Where I have y, I put d over 8. Then I square because there's a square there. Now I just need to simplify this, right? This and that gives me 1 over, root 3 over 4. So if you take this number and divide it by 8, because 8 is at the bottom, will give you that, right? D times d squared. Then minus, here I need to do this first. It's 8 root 3. Then I need to square first. So I'm going to have d squared over 64. Right. Then this will give us square root of 3 d squared over 4. Right. 8 goes 8 times into 64. So I'm going to be left with minus square root of 3 d squared over 8. Right. So I need the LCD to be the same. So I'm going to multiply this side by 2 so that I can have 8 both sides. So this must also be multiplied by 2. Now that my LCD is the same, I'm going to have 8 at the bottom. Here I'm going to have 2 root 3 d squared minus 1. Remember there's a 1 here, right? Minus 1 root 3 d squared. So 2 root 3 minus 1 root 3 is root 3, right? So I have root 3 d squared over 8. And that's the final answer to that question. Danko, I hope this was helpful. Please share with family and friends. And if you haven't hit the subscription button, please don't forget to subscribe to my channel for more content like this. Thank you very much, ladies and gentlemen. Till we meet again in our other episode of Maths Fanatics 24/7. Danko.